I was 16 years old and I was diving in Greece, and suddenly I realized that I came across more plastic bags than fish. I thought, well, why can't we just clean this up? So then I came up with this passive system that's attached to the seabed and really allows the ocean to clean itself. And now we've been able to show that with one system, in 10 years' time, we can clean up half the Great Pacific Garbage Patch.
2050, plastic wastes are estimated to outweigh fish in the oceans. This is because our unsustainable use of plastics and our lack of an efficient way to recycle or discard them. 95% of the plastic we use is thrown away after just one use, and of that plastic, only 5% is actually recycled properly. The majority ends up in a landfill, and about 30% ends up in the ocean. That's 8 million tons of plastic waste being dumped into the ocean every year, which is the equivalent of dumping a full garbage truck's load into the ocean once every minute. There are many negative consequences of this. Over 600 species of marine life are known to suffer directly from plastic pollution. 90% of seabirds worldwide have been found to have plastic pieces called microplastics in their stomachs. Fish also consume these plastics, which not only makes the fish unsafe for humans to consume, but can also cause that fish to die from the toxic chemicals. When this happens to many fish, their population will diminish. This means that there will be less fish in the ocean to start with, and the ones that remain won't necessarily even be healthy to consume because they may contain toxic chemicals found in plastics. Using conventional methods to remove all of the plastic from the ocean would take thousands of years and billions of dollars to complete. The ocean cleanup created a system which is predicted to reduce the Great Pacific Garbage Patch to half its size in just 10 years and at a fraction of the cost. The system is able to collect trash by relying 100% on ocean currents, meaning that there is very little impact on the aquatic wildlife and almost no emissions throughout the entire process. To make the oceans healthy again, the first step is to remove all of the visible plastics on the water's surface. By removing these plastics from the oceans, we prevent it from breaking down into smaller pieces called microplastics, which can be eaten by fish where they enter the food chain. When fish consume plastics and then humans consume those fish, it can be very dangerous and has been thought to cause various types of cancers, reproductive problems, nervous system damage, and other disorders. Because so many millions of people rely on fish as their main source of food, it's essential that the oceans be able to sustain a healthy ecosystem and that we minimize the amount of health issues caused by these plastics.
The ocean cleanup is a simple design that is made to be as flexible as possible. It uses solid screens instead of nets so it doesn't catch any fish or other animals. The screens are aligned in a V shape, which allows it to use the waves to push the plastic towards the middle. Each screen has multiple sensors in it to track every wave motion. The data from those sensors is used to further develop the system, making it more resistant to severe weather conditions. At the center of the V is the extraction point, where all the debris is collected and buffered. After extraction, you are left with a semi-finished product that is shipped to land and then sold to B2C companies.
The ocean cleanup is currently funded through a combination of corporate partnerships and philanthropic support, through which they hope to develop a prototype system for the Pacific sometime next year, which can be added on to more as funding becomes more available. On the longer side, once the initial systems have been installed, the ocean cleanup aims to make the cleanup operation self-sustainable by recycling and selling these collected plastics back to corporations on land. The belief is that once these companies realize just how lucrative these ocean plastics can be, that they can be repriced as a premium good, because consumer testing shows that people respond well to environmentally friendly products and are willing to pay more for them if they feel it helps the planet. So far, the estimated costs for this system are around 317 million euros in total, or 31.7 million per year when depreciated over 10 years, which translate roughly to 4.53 euro per kilogram of collected ocean debris. Manufacturing, deployment, and testing of the North Sea prototype is budgeted at 1.5 million euros, a third of which is contributed by private donors. In addition, the government of the Netherlands is committed to contributing another €500,000. The remainder of the funding has also been pledged by an anonymous philanthropist.
Global adoption of the ocean cleanup isn't as unrealistic as you might think. They made the most successful nonprofit crowdfunding campaign in history by raising $2,154,282 in just 100 days. Not only do they have the funds to accomplish their goal, but their donations came from 160 different countries. meaning people from all over the world are on board with the ocean cleanup and want them in our oceans. The ocean cleanup isn't a perfect system, though. It is able to get the bulk of debris in its area, but can't get the billions of pieces of microplastics that consume our oceans. Many scientists also question how the cleanup will affect sea life in those areas, and if it is actually the best way to tackle the problem of ocean plastic, or if it is just a distraction from the bigger problem that is pollution prevention.
For all the likely good that the ocean cleanup project would do, there are those who have major problems with its methods. One major criticism of the system is that the nets used to collect and harvest plastics may be too immense and disruptive to the natural environment of ocean flora and fauna. Buoyant organisms like Valia or purple genetha snails that float along on the surface would likely not be able to flow beneath the array's screen as planned. The potential for bycatch is too great to be ignored. Bycatch is more commonly associated with marine life becoming tangled in nets due to commercial fishing, but the critics of the plan argue that the same threats exist here. Another potential issue is the growth of passive plants and mollusks onto the stationary platforms and nets. The worry here is that the array will develop its own microsystem of sorts, and that plants and mollusks will attempt to grow on the array, decreasing its efficiency. A final concern, and perhaps the most potent argument against the ocean cleanup, is that in essence it doesn't actually solve the plastic problem. Yes, plastics will be removed from the ocean and reused, but unless a major piece of humanity makes a lifestyle change and starts to recycle and live responsibly, many of these plastics will likely end up right back in the same oceans they were fished out of to start with.